As Sam said, my name is Peter Fager. I am a senior mechanical engineering major. I'll be talking to you about the solar array that I was part of constructing and installing on a training center in the town of Ferrier, Haiti this summer with Engineers with a Mission. So a little bit of background on our trip. The purpose of the trip, there's a training center in the town of Ferrier that is run in part by Mission Waco. And they were using a generator to power the entire training center, and this is very unreliable. They had to find gas all the time. It would break. They only had a couple of people that knew how to operate it. It wasn't a very permanent solution. And so what they needed was a way to provide power reliably and continuously for the entire house. And so the solution, our proposed solution, would need to be reliable. We would need it to produce a certain amount of power for its entire lifetime. We need it to be durable. Haiti is on an island, so you got hurricanes that come through, there's thunderstorms, there's all kinds of elements, there's a lot of heat, and so we wanted it to be able to withstand those elements. Then we would need security was another big issue because, what good is installing power if the next day someone comes and steals it? So we wanted to make sure it was theft-proof and try to make it as hard as possible to steal these things. And we also want to use locally accessible materials. We didn't want to bring almost anything in from America because, if we brought everything in from America and then it breaks, there's no way they can fix it. So we want to make sure the materials that we use were locally accessible and that the people of Ferrier could get more materials if something were to break. And so, as I said, our proposed solution was a solar powered system. And we had to do a little bit of playing around with the number of panels and the number of batteries we would use to find the optimal power as well as lifespan of the batteries. Ran through some data, using data from average, sunshine in Haiti and that kind of thing. And we eventually settled on using 6 panels with 12 batteries. And once we had that down, then we could start working on the mechanical design, which is where the majority of my work was focused. This is actually a SolidWorks model of our design. Also, the sheets you have are this picture. And this is, we were in contact with a guy who lives in Haiti and does this for a living almost. He goes around and he installs solar panels on people's houses. And so we were talking to him, hey, how do you do this? What are some ideas? What are some things we can use? And his suggestion was to use angle iron. He also gave us a couple other suggestions, keep the panel so high off the roof, that kind of thing. But angle iron was really the biggest thing that he told us. And so we were given the specifications of the panels we were to buy and said, we want to use angle iron. Go. So we had to come up with the design and the layout of the structure. We went through a couple of different designs. The first one was wide enough for all 6 panels to fit on it. But then we realized, we don't know what the roof is going to look like. We don't know what our terrain is. So we've got to, we need to make this, give ourselves a little more flexibility in this. So we settled on a design that would have 3 panels with 2 racks. And as you can see, this is also at an angle. One of the things about solar panels is that in order to optimize the efficiency, you want to put them at an angle of inclination equal to the latitude of where you are. So for Haiti, that's 19 degrees. That caused a little bit of issues with getting the exact dimensions on these members here. We wanted to make sure we didn't have any weird numbers. We would be manufacturing this in the Dominican Republic, so we didn't want to end up with 23.274 or something weird that we would never be able to cut in the Dominican. And so that changed a little bit of our dimensions on the rack, but we were able to work around that, and we got pretty uniform, pretty standard links on all of our pieces. That way it was easier for manufacturing purposes. Again, we wanted to go with durability. We needed to think, this is steel, so if it rains on it, it's going to rust. We got to work around that. Theft deterrent. One of the suggestions we got from the guy we were in contact with was to use an angle iron locking piece. And so essentially what we had the angle iron that the solar panels would sit in. We actually used 2-inch angle iron for the solar panels, but we used a 1-inch piece for the locking bar. So you have the solar panel in here, and then we used another piece of angle iron we laid over top and then welded to the structure. And that way the solar panel, you couldn't pull the solar panel out. And that was really the biggest contribution we received from the man we were in contact with is using that angle iron to lock in the solar panels, because again, we wanted it to make it to where they'd have to cut through metal to take these panels. And again, availability of materials, we used a local vendor and used a local machinist to manufacture everything. Again, we used the brother-in-law actually of our driver was our machinist, and this is actually his shop. And so once we bought the materials, we took them over to the shop, and using drawings we'd made in SolidWorks, we marked the drawings. We had a couple people outside the shop marking the drawings, okay, this is how long we want it, this is where we need the holes, again, based on the drawings we had made. And then we would take them in, and Manuel would cut the metal and then drill it. And that was what we used. And that was, it was really very much a third world manufacturing process, but it was effective. We had the people designated to mark and get it, and then we had the people cutting and working with the materials themselves. Once we finished that, we then went back to where we were staying in the Dominican to assemble. We were like, we really want to make sure this is going to work and it's actually going to go together before we get to Haiti. That way, we still have a little bit better access to materials and stuff. And so we brought it back to the hotel we were staying at. It's a really good thing we decided to assemble because we discovered some manufacturing issues. If you look at the model, there are lefts and rights on the angle iron on either side of the solar panels. And they're very distinct, lefts and rights, and a left can never be a right. Well, we ended up with all lefts. So we had to work around that, and okay, we're gonna have to do some re-drilling, figure out where, what panel or what pieces we can get to fit and where we'll need to drill. But thankfully we were able to discover all of those issues, and we were able to work past them and get it all to work. Once we had the entire assembly together, we realized, okay, we're gonna have to take this apart to get it to Haiti. So, and we really don't want to have to deal with trying to figure out, okay, did this one go here, or was it here, was it with this piece? We didn't want to have to figure that out. So we came up with a labeling system and labeled every piece at every single joint. And like, okay, this piece goes here with this one right here. That way, when we got to Haiti, it was like, okay, no problems, we just put it all together. And so then we disassembled, loaded the van, and went to Haiti. This is actually a picture of the training center where we were in Haiti. And we actually installed the solar panels on the roof in this area. You can kind of see a little bit, there's a lot of things sticking up out of the roof. Those will come in important later. But we also had to work around that as well. So once we got to Haiti, then we had to do a little bit of work with the electrical assembly. We knew how many panels and we had the wire and that, but we also needed to make sure that was weatherproof as well. I mean, it's not good when rain hits an electrical cable. So we wanted to make sure we could prevent water from getting onto it. And so we used a PVC piping system, which modified a little bit where we would end up putting the arrays, putting the racks. And then we also needed to ground the assemblies. And we had an original place where we were going to put the ground, but the location of the batteries inside the house changed and some logistics in there. So we had to pull it up and move it over, and again, had to just use whatever we had. We went through two very large rocks trying to hammer this in, and went through a makeshift sledgehammer, as well as finally got a real sledgehammer. But that was, we had to find what we had available and use that to get it in. And then we had the final assembly of our racks. We were able to get them together and up on the roof in an hour and a half with that labeling system. So once we had them on the roof, again, the first priority was weather protection. So we needed to clean off all the dirt. These pieces of metal were incredibly dirty. So we needed to clean off everything we could, any rust, anything on the metal itself. We needed to clean that off. And then we wanted to paint it with a rust-resistant paint. That way, when it rains, it doesn't weaken the integrity of the structure. And so that was really, those were the biggest things as far as weather protection on our racks. And then we needed to work on positioning. With solar panels, you want the solar panel facing directly north or south. That way, when the sun is rising from rises in the east, sets in the west, it is on the panels the entire time. And so we had to work with that, work with some a couple of devices, make sure we had the panels lined up the right way. And then we also had to be aware of our surroundings. As I said before, there's a PVC pipe here. We got some rebar sticking up. This one you can see the water tanks they had. There's a lot of stuff sticking up. So we had to be really aware of what's going to cast a shadow. What do we need to cut? What do we need to move? So again, we just had to be really aware of that. And then again, with our theft protection, we had the locking piece. But as well, we also we cemented the racks quite literally to the roof. We used concrete anchors at first, but they were going to come back over and lay another layer of concrete on the roof anyway. So like, hey, just cover it over the bottom. And in the end, the racks went together completely, the solar panels went in, and it's been reliably producing power for the last 3 months. So, thank you for your time. If you have any questions, we'll be available at the end.